this is our emission scan, okay, and it shows you the parameters, excitation wavelength, and the emission scan range between 400 and 600 nanometers. So that's just that probably won't change those parameters on the fluorimeter, and the only thing I had to fiddle with is the gain, because that's unique to this particular thing, and it might be different for the fluorimeter. So I'm going to put that in its spot, which is repeat. Oh, no. Okay, that one. Okay. So while I remember, I like to put in what these are. Okay.
Mm-hmm.
And it didn't look like there was any differences between the replicates, So you can just plot one, unless you, like you said, you may want to plot all three, show how reproducible it is. At least reproducible within one experiment. The next step, is you hope that it's reproducible between on separate days as well, right? Because we got a little bit different answer today than we did yesterday. But probably that was more experimental error, where I was just kind of sloppy.
Yeah, I believe today look like it's more improved than yesterday.
Yeah. I'm going to see if it'll just add that number on. No, it. For the longest time, I didn't know what DPA stood for. I didn't know his middle name. I just didn't know. I was like,
really?
What is this? I've been working with Deb for over eight and a half years now, and I swear the first year I didn't know what DPA was.
Yeah.
Okay, so do you want to plot all this data together? It'll be like what we saw. I don't think we need. It might be good just to show the averages and the.
Yes.
Okay. I mean, we're not going to do the average. We don't have to do that. It's good to show all the data, I think. The raw data. This is the raw data, not the average data. If we're doing, statistical comparisons like I was showing you earlier, then we have to determine the average and the standard deviation, but we're not going to do that because Deb doesn't care about that so much. But I can show you one thing, which might be good. Okay, we're going to plot. Let's see how that looks. That's a lot of data points. It looks kind of ugly, and I don't know why it chose those colors. Oh my God. So we might not want to show all the data. I mean, another thing I like to do, because it's picking up every 2 nanometers, which is ridiculous, but that's okay. So I think that all the data look within the replicates, they look the same, so
maybe just do just one row.
Yeah. And I'll just leave that there in case you want to look at them, right? The only problem is, oh, that's okay. They're right next to each other. That'd be right. The instrument parameters, which you don't need. And you have Excel, right?
Yes, I do.
Okay. So see, that's a lot of data points. One thing we can do, but you have to do them all at the same time, is if you can like make it smaller. No, that didn't help. Okay. If you don't like to show the data points, each data point every 2 nanometers, you can go to change chart type and just do a line.
Mm-hmm.
Okay, that's just more clean looking.
Mm-hmm.
Okay, I didn't spell anything wrong, and I got a capital there. Okay. Here. I'm gonna go ahead and so yeah, we want all this data. There's nothing we want to cut out. This is like really
Yeah.
good.
If it got out, I don't think it should be.
Yeah, it's a good range of data. It's cut off here because we start to run into the excitation. If the excitation wavelength overlaps the emission wavelength, you'll have a spike right there. I can show you that. I can show you that. I don't know. So say, let's just say I don't want to start at 400. Let's just do it for 1. So you can see what I mean. Say I start the emission wavelength really close to the excitation wavelength. Let's just say, I don't know, 360. Let's just see what happens here. This won't. Okay, see, it says crosstalk.
Mm-hmm.
And so if you look, is that I don't want to do that. So let's see if I go to 370. There's still crosstalk, but I'll show you what it looks like. You'll have a spike because it's too close to the excitation wavelength. So that's why it's kind of cut off right there at the beginning,
Yeah.
because that's where you're going to see that spike. In that you don't want that. It's not.
It's not that important.
No. And Hux is really nice overall because you just got a very wide window to work with. But when you're doing the scan, you got to be careful. Even just for one, it takes a while. Because it's going from 400. Yeah, it's going even longer because instead of starting at 400 to 600, now it's like at 370, so it's got an extra 30 nanometers to take data from. See? Spike.
Oh, yeah.
It's just too close. So, and we probably, if you wanted it to go down to baseline, if you wanted it to go to baseline, you probably could start at 380 or 390, but let's just,
The
what I'm
other
saying?
one start at 400.
We started at 400.
Yeah, maybe by 360 maybe.
So you want to do it over? You don't like it? Okay. Yeah. That actually was a comment by
Because
a reviewer.
It looked
that
like
wasn't-
it's something have been cut off there.
Okay.
Yeah.
Okay.
Yeah.
All right, you asked for it, so we'll do that. Yeah, I agree, because we had okay, so I'm going to go ahead. Do you want all the data? You do, right? Okay, so, but let's just make sure, I shouldn't have, okay. 350, 370, 380. We'll try 380 and see if it gets it closer without the spike.
Mhm.
But in any case, we can always just plot. We don't have to plot the spike. That's true. Okay.
Yeah.
All right, so this will take a while. So in the meantime, while that's doing that, and so we don't like that. Delete. We don't like any of this. We'll just delete it because we're just going to redo it. So back to the excitation scan.
Mm-hmm.
Again, I think the replicates, when I looked at them, looked fine. So,
We didn't plot that. The
we plotted it
fluorescence.
earlier, but I think I changed the gain a little bit, so this would be a higher number. So you can show this.
No, that's the one that we run yesterday that you keep overnight.
Oh yeah, you don't want this.
Yeah, we don't want this no more. It's what we are trying to reproduce right
Yes,
now.
yeah. So this is
Yeah, I was talking about this one.
yeah. This is a repeat.
Yeah.
This is today's data, and I haven't plotted it yet. So
This one.
that's what we're doing now. We're repeating that. Took it away. We're
Oh.
repeating that right now. This is the emission scan now, where it's been cut off.
The
This is
fluorescence emission scan.
Yeah, that's just where I erased that data completely.
Okay. Yeah.
Right.
It's just you just take it out now.
Yeah. So if we look at it now, basically we're gonna plot the data starting at this point.
Yes.
You know, not at 400 where it looks like some of the data's cut off. This is a little closer to baseline. Okay, but it's gonna take a while to go through all that.
Mm-hmm.
I just meant in the meantime, let's look at the excitation. This is excitation. What's the best excitation wavelength to use now? Because there was some doubt. You might want to show this too, because I mean things can change depending. Yeah. So yeah, even though the absorbance spectra all look like they have the same maximum absorption peak, and you usually use that wavelength at the maximum absorption as your excitation wavelength. Because that's where it's gathering the most light, is at the high part, right?
Mm-hmm.
But we just do an excitation scan to see if that matches.
Okay.
But yeah, you would kind of, this is what you would show. I don't know why I had to put an N, this is supposed to be the other. You're probably going to say, I don't like the way that's cut off either, right? But excitation scans are faster, so I can go out further than 400.
Oh, yeah?
Yeah. So they all look the same. Compared to yesterday's data, they don't look the same. This is the excitation scan from yesterday's data. See, they don't look the same, but today they look the same. So something's.
What's that mean when it look the same?
That means the excitation wavelength. Mainly the excitation wavelength looked the same yesterday, but this was 162 was low, which surprised me.
Oh.
But today they all look the same, pretty much.
Okay.
So what I'm asking,
if you can increase the wavelength to 400.
yeah, I think, what did I go to? I guess I didn't go very far. Okay.
It doesn't go too far.
Okay.
Maybe by selecting the plotting area.
That's all the data I collected.
Oh, okay.
I'm saying I'd have to repeat the scan.
Yeah.
Okay.
Okay. One more thing. What's the difference between the emission and the excitation?
Okay. So in an emission scan, we're trying to find. Did I plot it? Okay. In an emission scan, this is emission, fluorescence emission. We're trying to find the wavelength where we see the maximum emission. Because when you do your single point screens, you want to use that wavelength. Yet that's what you're going to want to detect.
Okay.
Because before, these are single point. This is but this is a single point, okay? It's just a single point at the emission maxima, which was 452. These are all single points. This is not a scan, okay?
Mm-hmm.
You know what I'm saying? Oh, I don't have the data on here. These are all single points. This is the emission at a single point. The emission at 454.
Okay.
Okay.
Mm-hmm.
The scan I'm going to take some of this data out. The scan scans, from 400 to 600 because we want to see where the emission maxima really is. We just chose 452, okay?
Mm-hmm.
What we want to know, we chose 452 based on what we saw online, back here. But we don't know if that's the emission, that wavelength will give us the emission maxima. We don't know that. Like here, it looks like it's, we decided it was not 452, but 462.
It means the emission wavelength for the ox.
The maximum.
The maximum
brightness.
for that ox, the one that provide in the literature, it was 452.
Yeah. But see, that's different conditions. I don't know what solvent they use. We used cacodylate buffer. They might have used methanol.
Okay.
I don't know. But in cacodylate buffer, it looks like 462 is where you see the maximum brightness, the maximum fluorescence emission.
Okay.
Not at 452. It's not that different. You know what I'm saying? It's like about 10,000?
Yes.
10,000, is that right?
10,000 more than.
Yeah. Oh, not 10. Yeah, 10,000. 33, 34. Or maybe it's 500. I don't know. It's just saying, okay, our emission maxima looks like it's around 462. It's not what's reported in literature, in our system, in our buffer. It's not that different. We could probably just use this anyway,
Mm-hmm.
So I'm going to go to here. I'm going to take out everything that is confusing, okay?
Yeah.
This is our first trial.
What's this titration, duplex dilution, ox fixate?
Okay,
What's that?
So, I knew if I did too much, it would get confusing. This is where I remember here. I just did DNA, different dilutions of DNA.
Yeah.
There's no emission.
Yeah.
in here, all I did was I added Huxt at 2 micromolar to each of those dilutions. That's all I did.
Oh, it means like it's a ox plus duplex.
Right, right. Here, there's no Huxt. There's
Yes.
no emission. You wouldn't expect there to be emission from your duplex.
Yeah.
It's just in triplicate. But instead of wasting it, I just decided to add the Huxt at 2 micromolar.
Yeah. And what
across.
experiment can be called? It's kind of like a.
Oh, okay, so let's name it. Um, um, ligand binding. You can't make it too long. So, I guess I can say concentration dependence. DNA concentration dependence on. Yeah, I can't. I don't know. I'll just say the duplex concentration. I can't put too many words. Vary. Okay, that's all I did. Is the duplex concentration is varied,
Mm-hmm.
and then I added 2 micromolar of Huxt to that.
Okay.
It's just
So-
showing that the more DNA you have, the more fluorescence. The less DNA you have, the less fluorescence. There's less. There's so in this case, there's a lot of free Huxt floating around that's not fluorescent because there's no DNA to bind to.
Mhm. This is low with a low concentration.
Yeah.
There is not a fluorescence.
Let's make this too. Instead of nanomolar. I just want to change that. I don't like all this. The reason why I use nanomolar is because I don't like all these. Do you see that?
Yes.
I mean, I don't like that many
yeah.
significant digits. So I'm going to undo it. Let's just stick it with the nanomolar. Is that okay?
Mhm.
So, oh wait, it just gave us good significant digits. Okay, never mind. All right, we're back to micromolar.
Yeah.
Now
No, no.
You. Oops. What happened? I just want to change this to micromolar now because that's what we're doing.
But here is no micromolar.
Oh yeah. Keep it all the same. Okay.
Okay.
So, my point here is I just wanted to show this is where if you're going to find a binding constant, you've got to titrate the DNA into a fixed concentration of your binding ligand.
Mhm.
This is for later. You don't have to show this data at all.
Yeah. Yeah, I understand.
If it confuses you, that's not what he wants you to do. I am sorry about that, but I have a feeling that at some point he's going to say, see what happens when
Yeah,
you
yeah.
titrate
No
DNA."
problem.
You know what
It's
I'm saying?
okay. Yeah, yeah.
So I'll keep it there.
Yeah.
Just maybe we'll
Do
move
not
it.
delete it. Just let's keep it here.
And I can
I'll
move
just-
it. I can move it away. I can move it like over here. Okay?
Uh-huh.
We can put up front the things that you need to be looking at.
The first one also was the trial one. You keep that one too.
Yeah.
Yeah.
Yeah. So these were just extra things that we did.
Mm-hmm.
Okay. So let's just put what we're interested in right now. This is the first thing you're going to show, right?
Yeah.
Okay. This, I'm going to get rid of this page. Okay? This was experimental on my part. We're gonna get rid of it. Okay. I'll save this as a different name, or whatever name you want.
Mm-hmm.
I think you want to keep this data. Wait, this is yesterday's data, right?
Yes.
Yeah, because we just did today. We just repeated that. Oh no, what? Oh, that's weird. This is just a hux by itself. Oh well, don't worry about it. It said over, but I don't know it's being weird. I think it's being weird. Wait a minute. So I don't like that now because I can't see what it really looks like. This is in the way. I can't get rid of it. We can only plot it. All right, let me go back to this. Okay. So this is good data as well. The only thing you don't like about it is it's cut off here. Right?
Yeah.
That's why we repeated. So you're going to have your absorbance spectra.
That's it for yesterday.
Yeah.
And this is what we was about to run today.
Right. And that's what we just did. Okay, so let's plot that data. I'm going to put this here. I'm going to put this here. Excitation scan, we don't want that one. We just repeated this one. We want that one.
Mm-hmm.
Oh, okay, you might want this one. Remember I said you might want a bar chart? Okay, instead of a line, we might want a bar chart.
Okay.
But you can decide whether you want that data, you want to show that data or not. So that's what I was thinking for slide 3, bar chart. And the reason why is because you'll probably be doing just single points and not scans when you're comparing more than one benzimidazole. Do you know what I'm saying?
No.
Okay, the scanning, the absorbance scans, the emission scans, and the excitation scans are just telling you how does your molecule look. You will always do that with a new compound that you make. But say you make a whole bunch of different compounds. I don't know. I guess what I want to say, maybe it's from my side. A lot of times I get like 50 benzimidazoles, for example. Well, I'm not going to do a scan for each one.
Mm-hmm.
Deb just wants to know which one's the brightest, and so I do the single constant. I don't do the full scan. I just do it at one wavelength. At the maximum, using the maximum excitation wavelength and the maximum emission wavelength. So let's go ahead and get this data in here. So you're going to have this, right?
Mm-hmm.
And then let's see what happened with this data. I just did that. Okay. This one is the new data. Okay, see it said over. Okay, we don't have to worry about that. Oh, that's not right. Something's wrong. You see? Oh, because it's 380. Okay. This is where it's overlapping the excitation and emission. So we can't plot this data.
Oh.
So now I wish I hadn't erased the other one. Because I think I started at 400 before, but that's okay. You know, let's just go ahead and copy this to where it needs to be. All right. I know I did some other things that have become confusing, but why not? A through M then, okay. Okay, there it goes, okay. And I like it because you got everything, how things work, okay. So, we can go ahead and plot it, and then we'll do that. We'll select the data and see how close to baseline we can get, so there's nothing cut off. We'll also redo the excitation scan so we go to a further wavelength. So we're not cutting off the right side of the graph now. And then you'll have the, then you'll have the same parameters, Oh, David's doing something. All right, here's what we'll do. Okay, so we do everything in triplicate. Okay. So we can do it like that.
Yes.
If we don't like that little spike, I don't know if we can get rid of that and still be it. So it looks like it's data cut off. So we can keep that little spike there. So we
Yes. So
it's not cut off. So that looks a little bit better.
yeah.
You don't want to show all those replicates, right?
Yeah.
Or
Just
do you?
maybe.
You do.
You think you do? I don't know.
It depends, or you can just do one. And, okay. Oh, plus duplex. Okay. What? Why does it have the first? You see what it's doing? It's putting this number in. All right. I don't know what it's doing. Oh, I see. It's giving that as a title.
It's giving that as a title.
Okay.
It's giving this second row as a title.
Okay. I see that. Oh, you can't do that. All right. Well, anyway, we know what we want to cut off. We want to start at,
Maybe.
I can't remember. Did we leave that one in?
Yes.
There.
There you go.
Okay. So, yeah. It's kind of hard to see what's going on, so I wouldn't plot all the replicates again. And those are replicates, you know that, right? Oh, I forgot to put plus duplex. My butt's hurting. This is like the hardest stool. Okay. Just type up. Plus duplex. Not necessary to repeat these. But you like the way it looks better with
Yes.
stuff being cut off. So we're going to do the excitation scan, which doesn't, as well, so we don't have the right side cut off. Okay. If I don't put a number in front of it, I told you it graphs this, but then sometimes it won't even give it the right value at all. It's so annoying. Okay. So I'll just copy this time. And then we'll see. And then you can fiddle with how you want the graph to look and being uniform. But maybe I can do this one. When you work with Excel, you'll get, you're just gonna have to work with it on your own and just fiddle with it and see.
That is big.
Is that okay?
Yes.
I mean, then you can clearly see that, this is the region of overlap between the excitation and the emission wavelength, which, it shows that you went as far as you could to get to baseline. Now, cyanine 5, you generally have it cut off because it's so, they're so overlapped. It's really hard to get it. I have an X there. All right. Again, yeah, so that's that. So if you're kind of wanting to make sure all the graphs look the same, you just copy that and say you want you want all the graphs to have the same dimensions and all that kind of stuff. Okay, you would just put them side by side. Okay.
They're some the same size.
Yeah, and then I really like that. I mean, but the problem is with Excel, you've got to do it. There's other graphing programs that you set the parameters of how your graph wants to look, and every single graph that you do will look that way. You don't have to do each one, and that's kind of a finicky thing about Excel. It's kind of a pain, but that's what you would do.
The axis here is what?
Is what?
The axis.
What about?
To title the axis. There is no title.
There's no.
Is a the
title
for the axis, so the dilution.
So, okay, if you want to change anything about this graph, like you want a title, you want a line there, you want to change font, but if you want to put the titles. All you have to do is click where it says chart elements, add or remove, change chart title, legend, grid lines, data labels. Then you would go to axis titles here. Okay.
Okay.
And once those are up, all you have to do for here is click here,
I
move
select
your
it.
cursor, or you can put it here, and you would, in here it's fluorescence intensity.
Je miss arrière.
I'm getting tired.
Yeah, I believe so.
I get up like at 5 o'clock, but I'm sure you get up really early too. I'm getting old anyway.
I'm sorry to take all your day on time. Sorry for that.
Yeah, it's a little
Yeah.
late for me.
Yeah, I guess so.
And yeah, we don't have to put anything. Yeah, so that's just fluorescence intensity. The other,
Okay, go ahead.
another thing that a lot of times if you look at the data, it says RFU. That
The
means,
unit.
that means the title for this
Oh, yeah.
is RFU, which stands for relative fluorescence units.
Okay.
But you would have to say you'd have to say in the legend that, this abbreviation means relative fluorescence units because it's relative to the highest
Of
fluorescence.
fluorescence.
Yeah. So I generally like to spell it out, and I like to put a line there. So I'm going to click on it and then right click and put a line there. I like a line. It doesn't have lines there for some reason. Okay, so we got it that way.
Yeah.
So we make them the same size, okay? And we make these the same font sizes, which, if you can't remember, you use this as 16, because that worked out good before. When we shrunk it down. Okay. Make that 12. I don't like, we went to 600, but see, the data point for 600 is there. It just cuts it off. Sorry. It's emission. This is absorbance.
Emission wavelength.
Okay, wavelength. Okay. And then we'll make that 16. Okay. So because, let's see. So the other thing that I hate about Excel is that, you have to kind of fiddle with each graph. So what I notice is that see how this is shorter? It's because these values are different. I would oh yeah, and I want to make this 12. Okay, so that's even worse, right?
Mm-hmm.
So that's why I was showing you that if you want everything to have the same proportion, generally I like to put this here where there's space. So I kind of shrink it down and I just move it over here to the top. Okay, and then make that long enough. There it is. So these are the titles you gave it. So if you want to change that,
No, the title should be this one.
no, I mean the legend.
Yeah.
This is the titles that you gave it.
Yes.
Where's the data? Oh, there it is. Okay. Okay, there it is. So
Oh, this is for the first
yeah,
row.
yeah. So you need
Those two, I will do
yeah.
that.
So you want to make your titles. So your titles, these are the titles you gave it.
Yeah.
So you want to have the same. You want to be consistent, is what I'm saying.
Yeah.
In the titles, I don't like to spell it out. I just like to have it be H.
Oh.
You know, or you can spell it out. It's just you have to remember you don't want your legend to take up the entire space.
I understand.
You can say this is Hux.
Us.
You know. I just will do it that way, and
That means down here too. You can just put H.
so the way we were doing it, or the way I was doing it, was H, the Hux, plus duplex, right? That's the way I did it before.
Okay.
Anyway, you can decide.
No, that's fine. That is a good way.
Yeah. So whichever way, instead of, and then you kind of have it kind of. So yeah. So you can fiddle with that. So that's why I also like to stack them. And I usually like to see if I can get them as close as possible. Put them in the upper right-hand corner. Just definitely maximize the space, okay?
Mm-hmm.
And then when I have it here, I'm going to do exactly the same here. Okay? And put it in this corner. Okay? I'm just saying, so, because see how this took up so much space down here, and then it squished this graph way down.
Yeah, and the graph look like it's so much wide.
Yeah, and then the
short.
size of this is different from that, and that'll drive Dev crazy. I know this is true. I know. He's like he really hates that. So I'm gonna bring this all the way down here.
Mm-hmm.
Oh, I'm not going to bring it all the way down there. Just enough so I can see that.
Yes.
Okay. So now that's that. I'm going to do the same thing with this one. And that's why that's the only thing about Excel. You have to do each graph individually. And kind of
Yeah.
Whereas other
that's just the form. And then it's very important.
Yeah.
Yeah.
So,
you look very good now.
Yeah. Yeah, and you make, if this isn't lined up for some reason, you can click on this and move it around, you can take your chart title off, right? We said that they don't do chart titles. The journals don't do that, so it's something you explain.
Wow.
So it's kind of I like Excel, but the problem is the graphing. You have to do each one
separately, because
your axes will be different depending. These values are very different. Observant. And so it's gonna, and then you may have more data on one than the other. And it's probably. So the other thing you might want to do is you might not want to plot all three of these data. You might want to do it like this.
Mm-hmm.
So you've got three graphs. So we plotted all the data together on this one. This one we're only doing 2 sets of data.
Yeah. So you think I should do this one also too, just to graph you
can,
the one.
And this is what you'll have.
Okay. Mm-hmm.
And so once you save this as a picture, when you shrink it down, you can have them all together, right?
Mm-hmm.
That's just aesthetics and making it so it's uniform. So that if it's not uniform, it leads for Dev. I know it leads to complete he can't stand that. Or if your colors are different or not you're not being consistent with colors, consistent with naming, consistency. So I mean, I think this shows what we need to show, but yeah, so. So what we want to do,
You take it out?
well, I don't know how you want to show it. Do you want to show it like this?
Yes.
Just two? Okay, so
But
that's,
just keep the other one.
oh, okay. All right,
This?
okay, oh, yeah, okay, okay, yeah, because you might want to show it different ways.
Yeah.
Okay, let me undo it. Okay, we'll leave it there. Okay. But that, you may want to show it that way, but yeah, so you're just going to sit here and fiddle around.
And then you
Okay, so.
it's the same thing here that we just arrange the form.
Right, okay. So I'm just gonna, I don't want to confuse by having copies and copies and copies.
Mm.
But I'm gonna put it over here. Okay. So here, we don't care about, cut that out and put it over here. And this is where we're just gonna separate them by type instead of graphing them all together. So I'll do this one and then we'll look at that excitation scan, repeating that. Remember?
Mm-hmm.
And there's another trick that I do, but I don't know if I can see it. Okay, I'm gonna just copy this, right? Because we're gonna have that under, right? So
Yeah.
you'll have your absorbance spectra, your fluorescence spectra, and then the excitation scan. But actually, it should be excitation scan before fluorescence spectra. So he may not be interested in as much. He's more interested. He's mostly interested in fluorescence spectra. Oh, did that again. See how it does it? It'll put that data onto there, and it's like, okay. Which is nice if you go in between sheets and you're like, oh, I wonder how that data would look on top of that versus on, not on top of it, which is good too. As long as, okay. And then, let me keep forgetting. Do you want me to just get rid of this? Our first trial?
Yes.
You do?
That was yesterday try.
Oh, okay. I'm just going to delete this. Yes. Okay. Let's just save this as. So I don't want to overwrite that because that data might be useful later on for my purposes, for example.
Okay.
Like in case you make benzobenzols and I need to check them or something like that. I don't know. So we'll do what? Final data
Yes.
for trial one. All right, there we go. And so you don't have, yeah, I don't want to confuse you with all these things to look at. It's just too much. You might want, okay, all right, so, where was I? Oh, I was taking, so if you can ever figure out how to do it without doing it the way I did it. it's up on top. If I select it from the bottom up, it'll put it at the top. But it says I always start from the top down and puts it at the bottom. Oh. Control-C instead of Control-V. Okay, just so that's there. That's for that one. That's for that one, okay. And so if we go back here, because we're going to do this stacking, we can just do it for Hux. Let's just do it for Hux, and then you do the other
yes.
one. And that would be good. Mess with it. This is a pain, but anyway. Okay, so that looks about right, right? Try not to be a perfectionist. Okay, because it's painful.
I believe so.
All right.
Wow.
Okay, and then, so for our excitation scan, we're going to rerun that, right? This is excitation now.
Yes.
Because that's cut off. I'll keep it here. If we have a nice, if this looks the same,
Yeah.
I'm going to erase all this so you don't have.
Yeah, do not delete it first.
Yeah, because who knows what'll happen. Okay. So here, I'm going to delete that because now, sorry. it comes up as excitation. So here is where I select between excitation and emission. Now we want an excitation scan. I'm glad I didn't delete it because I can't remember what values I went to. But I think, yeah, okay, so the parameters were, yeah, we were saying I only went to 380.
Yes.
It cuts that off. I started at
At
325.
325. Maybe we can start it at 355. At 350?
If we started at 350, we'll be right here.
No, 315.
Oh, 315. Okay. Or 300. How about 300?
Yes.
We can go really low.
Okay. Because
And-
I would
and
just
see
care
how-
that you can put the error, like the emission
Okay.
value.
Yeah. So what did we start? Well, here it starts at 386. We're going to have to go well below that. So, yeah, 300 to 400. How's that? And that should give us a nice shape. We're going to go ahead and collect all the data. Do you want to collect all the data?
Over there?
No.
What?
For the excitation. Yeah, we will.
What you mean collect all the data?
I mean, what we could do, if you don't want all the data, we can just do this one for Hux, this one, that's what I was saying.
Oh, yeah. Like we just plotting just with the one without the dilution value.
No, the
What?
dilutions are going this way. Never mind. We're going to collect all the triplicate sets. Okay.
Okay.
Yeah. Excitation doesn't take as long as emission. So we're going, what did I say, 300 to, I can't even remember. Do you remember?
300 to 400.
Okay, that should do it, because that's at 380. But see how high it is? Maybe we want to go a little higher. How about 500?
Yes. It's very high, that's true.
Yeah, okay. So 300 to 500.
Mm-hmm.
And our excitation wavelength is, our emission wavelength is 452. We just chose what we saw from the literature. We're not doing 462. Yeah. Okay, 452. Okay, we're not gonna worry about the the gain. Yeah, the gain I did change. Just okay. That won't take as long as the emission scan.
Mhm.
So excitation scan is much faster. So this is the last graph that I will do, and then you will do the other
Yes.
6.
Yeah. Let me show you one thing. You have the. For the emission. Okay. The wavelength emission will be same for the both
right.
of them.
So let's just put that in there.
Mm-hmm.
And just remember that little thing if you try to graph that. What happens is it'll graph the wavelength too. So if you go to insert,
You select the wavelength for the other plot too.
so see how it graphed the wavelength?
Oh yes. That's all.
That's why I put in, you can take that out, but see it doesn't even, it plots it from 1 to 100 instead of 1 to 60. I'm just
What's that mean?
okay. So do you remember? Do you know? Have you noticed that I keep putting a letter at the top and a
Yes.
letter at the bottom?
Yes, because
It keeps it from doing that.
yeah. So if when you put the letter at the bottom, it didn't say it at the axis level. Oh,
Right. It doesn't graph it,
yeah.
and it also it'll give it the real true value. This is only going to 100. It's not. It's starting from 1 to 100. Like I don't know why Excel does that. So that's why, and it's not enough to just take that out. It doesn't, the axis is still the same. It's not right. It's going from one, it's actually the number of data points. It's not the wavelength. So I'm just saying, try to remember. And when you put it in, you'll have to take it out so it's not in your graph. That's why I do it. Because I've tried, I think, making that text. It has to be data. I don't know why Excel does it, and I haven't found a reason why it does it. But this time when I graph it, it'll show the actual wavelength, not the number of data points. But now I've got the little n in there, so I've got to go back and take it out. So I can, when I take it out, that's good, it's gone. So I am just not sure why it does that. Okay, so yeah, I'll just put it. I'm trying to give space so they're right above the data. It's right above the data. That's right above the data. Okay. Yep, it's taking longer than I thought. Oh no. We have to stop this.
Stop that.
I must have not done something right. It's not even worth looking at. It's just gonna be. It's over in the. What did I do? I know why.
Why?
The excitation wavelength cannot overlap the emission wavelength. It's overlapping.
Oh,
You see what I'm saying?
yeah.
So we can't. We
you
have to go below. That's why I chose 390.
We had to go below the emission wavelength.
Yes. So that was just okay. Let's look at this again. I went to 380 last time.
Mm-hmm.
That's why we said 400, but we can try for. We got a bandwidth of 20. We'll do 425. Okay. Okay, it's still saying that. Okay, it's gone. No overlap. Are you learning anything?
My goodness. Biology. It's a biophysical.
biophysical.
It's not even
It's not
biology.
biology. We're using a biological molecule.
Well, I had this field when I was in undergraduate. I didn't like to learn biochemistry, physical chemistry.
Oh, physical chemistry.
Yeah.
Yeah.
My major was organic chemistry.
Oh, wow. Wow. So both of my kids have taken organic chemistry, and they say that's the hardest course. They say that's the hardest course of everything they've ever done. Okay, let's go.
Okay.
It's not over.
Okay.
But yeah, physical chemistry is a pain. There's a lot of math. There's a lot of yeah. I really like spectroscopy. I learned a lot of spectroscopy from my husband because I worked with him for 3 years.
It's the best chemistry forever.
He is a biophysical chemist. He's built his own laser.
Yeah.
He's done single molecule detection. Like and he's so good at showing me how to do things.
Me too. I like that to identify the compound, draw the compound through the spectroscopy. The mass. If you have the mass spectra, the NMR spectra, you have 2D NMR.
I don't know NMR. I like
Yeah.
I've done mass spectroscopy.
From-
I like that a lot.
From that, even if you don't know the structure of compound, from that, all those spectra, you can draw the spectrum, identify the spectrum.
Yeah.
All those information will help you to collect the compound, the structure part.
Yeah. I when I was got my PhD, I got my PhD at Clemson,
Oh.
and I got it in the microbiology department, but they don't have a microbiology department now. Microbiology went into biology. But anyway, I took an analytical chemistry class because I needed it for my thesis work.
Mm.
Best class I've ever taken.
Wow.
Really good teacher. She was in the plant pathology department, and she ran the analytical labs
Mhm.
for plant pathology. So I learned HPLC, I learned mass spec, I learned fatty acid. I learned all those analytical techniques, and I learned some spectroscopy. But she would give us a mass spectrum and tell us, and we had to figure out what it was, like what kind of compound it was.
Yeah.
So you look for signature things like 76. 76 is a benzene ring, right?
Yeah. You have to learn or have an idea of all those the range of the molecular weight, the classes. Yeah. So
Yeah.
if you saw like the imidazole ring, the imidazole ring have his specific class identification.
Yeah,
Yeah, something like that.
yeah. Well, we should all. You're invited to our party. Do you want to come to our party? You probably can't.
Where
We're having a holiday party on Thursday.
this
Here.
coming Thursday here in Clay?
Yeah,
I
at
don't
around
really-
3:00.
No, I can't.
I know. Sorry.
No problem. Maybe next year, if by God grace.
Dev won't let you. Dev doesn't like us to play. I forgot to ask Dev to invite us to our party so he can pay for the food.
He will be here. He will be here for
I
that.
haven't seen him for I want to say I haven't seen him for 2 months.
Oh really? I thought
I see.
he's coming here more.
On average, for an entire year, I might see him 10 or 12 times, maybe once a month, maybe.
Wow. I thought he visit here more than
I
Clemson.
thought he went to Clemson more than he was here. Where is he?
I never for the inter here maybe once twice.
Oh, really? Okay.
Yeah.
Well, where is he?
I don't know.
So So I have this joke. I did this to him one time. We're having our Zoom meeting, okay? We
Yeah.
haven't seen him. And I'll say, "Hey, Dr. Arya, where are you?"
And what he said?
He doesn't get, he's weird with humor. You might notice he's not a humorous person himself.
Yes, that's true.
And he kind of laughed a little bit. But, it's got to be a classic thing. Nobody knows where he is. Nobody knows where he is.
Wow.
And then he'll just appear, all out of nowhere. It's like, oh, hi, like, you know what I mean? It's like you don't see him and then one day there he is, and you don't even know like, oh, hi, All right, so we got good data. This data looks good.
Yeah.
We have a nice
shape.
Yeah, and we can't do anything about that.
Yeah, that's fine.
We forgot. We did go a little further. We could go a little. I don't think anybody's going to freak out about that. Please don't be a perfectionist, okay? At some point, this is a very nice looking excitation curve, okay? And then these guys are definitely not excited by light at all, because it only lights up with DNA. Okay, great. So that's our last set of data that I'm going to graph, just the one, right?
Mm-hmm.
Okay. So I think this little setup right here, the way you're doing it very simply, just to, with and without duplex.
To better understand.
Yeah, and don't put them all on top of each other. I think it'll be very clear that yes, indeed, you know how to do a duplex. Yes, indeed, it is reproducible when you bind the ligand. That's all you needed to show. That's all I needed to tell you. I've told you way more than you need to know.
Okay.
But I think you're a good student.
Yeah.
Okay, I'm gonna get rid of this.
I never done this study. That's just because I spent all last week by reading that paper to have an idea of what this study is talking about.
Yeah. Yeah. I mean, I've never done binding studies like this before. Until I came here. And so, it was like, oh my God, I don't know, it seemed, when you don't know it, it seems really hard.
Mm-hmm.
But you see, it's not hard.
Yeah.
You just didn't know it.
Well, since you know all the process and the protocol, I prefer that much better compared to synthesis. Require more time. If you know well, instead I spend all the time by doing preparation of each sample. It's just because I'm learning.
Mm-hmm.
You understand what I mean? It seems to be more easy than synthesis anyway.
Really? Okay.
Yeah.
Okay.
I believe so.
Good. Yeah. If you understand the principle,
yeah,
the actual doing the experiment is very easy. Understand
for
the
sure. Yeah.
The hardest part is understanding the principle. If you don't know the principle, then the experiment's impossible.
Yep, that's true.
You know what I mean?
Yeah.
So you understand the principles. It's so easy to set these experiments
That's
up.
how he was always. He told me it's something like an experiment, like a 2 hour. You get the fluorescence running. That's how they've told me. I said, how 2 hours?
Right. Yeah. It won't take you any time at all. It's very fast. Once you understand the principle, you can see, I just need to do this, this, and this. And then, sometimes it takes a little bit more because you may have to do a little bit of variation. But if you understand the principle, you know which way. If I do this, it's going to go this way. And so forth. No, I don't want to do that. All right. I'm going to do it just like. And those are replicates.
3342.
Okay, I'm already like, I don't remember. I
One.
think I'm getting loopy here. Okay. I'm just going to leave those there. And select the whole column to do that copy and paste. Oh, right, and then this one next to that one. But yeah. I'm just going to put that little letter in there so we don't have to worry about it. There must be a way to do it besides the way I'm doing it. And I've never figured it out in all the years I've been working with myself. Okay, so we're going to do this one, and then you're going to do the other 6 sets. I'm going to go ahead and make a space in between so you can set your graphs up between. Okay, so that'll be big enough so I can put this here, and then you'll have just so that, let's see, 1, 2, 3, 4, 5, 6. I've even had it. Sometimes I have to graph so many graphs. I've even had it where I have all my data laid out. This is my template. And I just transfer this data. You know what I'm saying? Here.
And what happened?
Nothing. There's so much alike. Okay.
Yeah.
Okay. Never mind.
Yeah.
All right. All right. So we're gonna copy that onto our. So the absorbance spectra is kind of just showing us our template. And B. All right. There we go. There's our data. And you'll have the axis titles up, just for this set so that everything will be uniform. I'm going to take those little letters off. If you don't take them off, it won't matter, but it's just something that's, one day I'll figure out how to do it. What'd you do that for? Okay. So if you see it do that, you see how these are pointing this way, and these are written across?
Huh?
The number is written across instead of up and down.
Oh, yes.
I don't know why it did that. It must have been the order in which I did things.
And this one too.
Yeah. I like it like this. I don't like it like that.
Yeah.
They run into each other. And if I make that font bigger, like because I want it to be big enough to see, it's even worse. Oh. Well, I don't know. Okay. Okay, never mind. So it's the font.
Exactly.
Sorry.
You're good.
Okay, Okay, and then I just see I'm getting very tired. There's an extra space, and that makes me mad. Just good. That's good. All right. So yeah, so what we were doing. Oh yeah, so let's make sure all the fonts are the same between the graphs, this font size. That's weird, it switched back. I thought see, it switched back. So anyway, if you see something like that happening, double click, it brings this window up, and this right here, size and properties, I can change the text direction to the way I want it. I don't know why I did that. But yeah, if I were, like, if you see that again, you know, even though it's, the font size is 12, okay? And when I changed it to 12, it's still 12. It's still, like, I don't want that. So you would double click, go to this little square with the arrows, and then you're going to choose the text direction. We don't want it horizontal. We want it rotated 270. Okay. And now that's good. Okay. I'm going to make sure that's 12, and I'm making that 12. We're going to add our axis titles, and this is
Fluorescence.
Oh wait, do you remember what the axis title was? I guess it is. It's fluorescence. Okay, it is. Sorry, obviously that's fluorescence. Okay, so I would show it in this order: absorbance, fluorescence, scan, and then excitation. Because it's very easy to be confused. Is this an excitation or emission scan?
Yeah, I don't see also the difference till right now.
So the only way you can do it is that y-axis is going to be emission, and this is going to be excitation. Excitation wavelength. So I guarantee you he's going to be like, what's the difference between that and that? And it's just like, you've got to make sure you've got the, you know, the label there. So this is excitation wavelength. So our emission scan or excitation scan.
What's the difference between both of them? How will you keep asking that
Yeah.
question?
Yeah, no. And that's, I think that'll be okay. So let me just finish this. I'm going to make sure that these are all the same.